This is an introduction to arrays and loops in Python, and what we're going to be doing for this is using Numpy. Okay, so Numpy is an add-on package. It's a module that you can add to Python to extend its functionality. For those who have used MATLAB or other numerical analysis tools, it's going to be very similar to that. But we want to create arrays. Now arrays can be either vectors or arrays can be matrices. Okay, and now these are going to be one-dimensional, and then these are 2D plus, multi-dimensional matrices or arrays in Numpy. Okay, so we're going to come to the course website. Okay, and if you just come to the Introduction to Programming, and so this is APMonitor.com/CHE263. And then come over here to the homework. We're going to be doing assignment number 8. Now if you want to, you can check out this the PDF version of this, or if you want to download an IPython notebook, they'll download it as a zip file, and then there will be the IPython notebook inside that. Don't forget to extract it just wherever you're going to use it. Okay, so I've extracted that, and then I'll copy it over to my desktop. And so I need to open this. What I'm going to do first of all is just go and open an IPython notebook. I previously downloaded Anaconda. This is Python 3.5, and then I just type in this search. I do Jupyter Notebook, and then go ahead and select that. I can minimize this this screen right here. Don't close that, just minimize it, and then it's going to come up in your browser with the local host, and it's going to be here on this tree. If you don't have it installed, just come to try.jupyter.org. okay, and then it's going to start a new notebook. So this is a very similar environment. If you don't have it, you can come here to try.jupyter.org. Okay, so here is homework 8, the IPython notebook. Okay, and what we're going to do is just go ahead and go through some of these problems related to arrays and loops. Okay, so here I'll just insert a cell below. Okay, so first of all, we want to import Numpy. So there's a couple different ways to do this. This is probably the most common. You can import Numpy, but then whenever you want to use it, you have to do numpy dot something, okay, using that package. But what we do is we shorten that name just a little bit, import numpy as np. Okay, and that makes it so that we're just shorten this just a little bit. Okay, and then let's say I want to create 50 ones called x. Okay, and then I do numpy, and then I can do numpy ones and make 50 ones. Okay, and then let me go ahead and just print x. Okay, so there are my 50 ones in a vector. Okay, if I want to print the length of x, for example, okay, I can see that it's 50 long. Alright, so that's a new vector. It's called x. And then for the next one, I want to create an array from 1 to 20 with 50 equally spaced elements, 2 different ways, using a loop and a single command. So within Numpy, there's a single command that's called linspace. Okay, so let's go ahead and do that. The 2 arrays, I'll call one of them y, and I'll do linspace. Okay, and then I'm going to do the starting point, ending point, and then how many values I want. Okay, and then let me go ahead and print y. Okay, so there are my 50 values between 1 and 20, equally spaced, linearly spaced, and 50 values there. Now let's say you forget how to use one of these functions. Google is going to be your friend. Other search engines. You can also do help np linspace. Okay, so here is some help. for you as well. Help on function linspace and module numpy.core.function base. Okay, so here you have the usage, right here. This is the usage for linspace, where you have the start, stop, and then number. There's some other optional arguments as well. Okay, so the only ones that you really need are the start and stop. The next one is going to be number equals 50. That's the default. So if you leave that off, it'll just put in 50 there for you. Okay, so you just need the start and the stop. But if any of these have defaults assigned, it means those are optional. Okay, so you just really need the start and the stop, as we just showed. Okay, so there's the help. I'm going to take off this help because okay, and then if you just have 1 to 20 and then print y, that'll also give you the same thing that it did before. Or we could have, maybe you only want 10 points, okay, between those. Okay, so there are 10 points between 1 and 20. Okay, let's set it back to 50, and then let's go ahead and do z. Now we're gonna have this one be just go ahead and create either a blank ones if we're going to be defining them. So we can do empty array of size 50, and then we can define those. Or if you just want to set them to zeros, you can do that as well. Okay, so I'll just set them to zeros first of all, and then I'm going to create a new loop for I in range 50. Okay, so that's going to start. Let me just go ahead and print I. Okay, so that's going to go through and just go from 0 up to 49 or 50 entries. Python always starts with index 0 in that range. You could also do range 1 to comma 51 if you want to go 1 through 50. Okay, so there's 1 through 50, but common Python is that you just start with index 0. And then what I'm going to do is take this z vector, which is all zeros right now, and then the ith element of that, I'm going to set that equal to I times 20 minus 1. Okay, so that's my range, and then I'm going to divide by 49 and add 1. Okay, and then let me go ahead and print z. And there I have the same thing that I had on y, but let's go ahead and just compare the two. Okay, so I had just very slight differences there, just machine precision kind of round off. So they're essentially all zeros. Let's go ahead and just sum those up. Okay, sum up the, and I want to do the absolute value of the difference between them. Okay, and there is the sum of the absolute value of the z minus y. Okay, so z minus y, the reason why I did absolute value, some of them might have been negative, some of them might have been positive. I just want to see the total absolute difference between the two. So I put this, this was another vector with all positive signs, and then I had the numpy sum function, and I put that vector inside it just to sum up all the differences. Okay, so that's the first problem right there. Now let's go on to problem 2. We want to import a Python package called random. Okay, so that's another package within Python. We'll come back to NumPy in just a little bit, but let's just go ahead and create some random numbers. Okay, we want to create a matrix M as a 1-by-1 NumPy array value 1. Okay, so this is not random yet, but we'll go ahead and import that. So I'll go ahead and insert a cell below. Okay, so create this matrix. I'll just say my matrix is going to be M, and that will be just ones of size 1. Okay, and then I think it helps to print this out as well. Just make sure you got what you were hoping for here. Okay, so that's different than just saying it equals 1. Let me go ahead and comment that second part out. So that is not in a vector. You don't see the square brackets there. So we're going to have this be one with square brackets around it, meaning that it is a vector of size 1. Okay, and then what we want to do now is go ahead and create a while loop and append a random integer between 1 and 10 to the end of matrix M until the last element is a 7. Okay, so we're going to set up another loop now. We're going to set up another, in this case we'll do a while loop instead of a for loop. Now a while loop, use that if you don't know when you're going to end, for example, and then you use the conditions in the loop to tell you when you're going to break out of that. Okay, so we'll go ahead and just set up iterate, I equals 0. Okay, so because we don't want to go for more than 30 of these cycles as shown in part D. Okay, and then we'll do while, and then we'll say M. Then the last one, the last element in that vector, we'll say that is going to be the -1 element. Now I'll show you how, as we build that up, I'll show you why that's the case. So when it's not equal to, so to do the not equal to is not equal to 7, then we'll continue adding to this vector. We'll do that with the numpy.append. Okay, and we're going to append to that, after we import the random, import random, then we can use the random. Let me make a new integer here. So I'll have a new integer. I'll call that n, and that will be rand_int. Okay, and that's going to be 1, 10. Okay, so it's going to be a random number between random integer between 1 and 10. And I can just append that to the end of M. Okay, and then we'll say that I equals I plus 1. A shortened way to do that is just do the equals plus 1 there, but we'll do the longer way. Okay, so if I is greater than 30, then we'll break this. Okay, so we broke that, and we didn't want to. It'll also break it if it's equal to 7. All right, so let's go ahead and execute this one, and at the very end, what I need to do is print M, my vector M. Okay, so you're always going to get either a size of 30, or you're going to get it to end in that 7. Okay, so in this case, it went all the way to 30 before breaking it. It's just random numbers. I never got a 7. Okay, so in this case, it went all the way to 30 elements. Okay, and so if I insert something below, okay, I'll insert a cell below. Let's just see how many elements were in M. Okay, so I'll do the length of M, and that gave me 32. Or I could have done print length of M. Okay, that's 32. The reason why it's 32 is you always append and then you check if it's greater than 30. So if you only wanted that at 30, you'd have to have broken this at 28 instead. Okay, in that case, it was only length of 2. Okay, now I promise I would also show you, if you do M and then you do -1. Okay, so let me do -1. It's going to go all the way to the very end. And if I do -2, it's going to cycle back and do the first element. So if you think about these like kind of looping around on themselves, then the index here, you normally start off with 0, and that's also going to be 1, and then the M1 is going to be 7, and then if you do M2, then you're going to get an error. But if you want to go back the other way, -1, 0 is going to be, 0th element is going to be 1. So I'm just going to go back one more, and that kind of loops around to this, this 7 right there. Okay, so that's why we use the m-1. That means the very last element of my vector. Okay, so let's go ahead and do the rest of this problem. We also want to report the number of elements of m and the mean value of the elements after the loop. Okay, so we want to get the average value as well. Okay, we already did the length of m. Okay, and then we also want to get the average as well. So I'll go ahead and just do, you can do numpy mean, and that will be the average. Okay, and the average is going to be 4. 1 plus 7 is 8, divided by 2 is 4. There's another way to do this with a numpy function as well. You can also do size, and that basically does the same thing. I'm going to re-execute this one, okay, and then if I execute this next one, you'll see the stats on m. Okay, let's go on to problem number 3. Okay, so we have the following array A. We want to reshape the array to a 5 by 5 matrix. So let's say we just got this sequence of numbers and we want to put it into a matrix form. There's 25 elements to this array. You got to kind of scroll over here to see all of those. And then we'll loop through each element of the array. If the element is 5 or 8, we'll print the element index, okay, so where it's located. Also keep track of how many 5s and 8s there are with a new variable which we call k, and we'll also print the k. And if the element value is a 1, we'll print you win. Okay, so let's go ahead and come in here. I'm just going to go ahead and insert a cell below. Don't forget to run this one, Control Enter, so you see a number there next to the in this case it's 32. Okay, so we're going to then reshape. Okay, we'll do a reshape function, and we want to reshape it to a 5 by 5. Okay, let me go ahead and print A in that case. So I've reshaped that into a matrix, a 5 by 5 matrix from the 25 elements that were there before. If I put something, like I try to reshape it into something that's a different size, then I'll have an error there. Okay, but it has to be 25 elements in this vector. If I do something less, then I also get an error there. Okay, so it has to be 5 by 5. Okay, so let's go ahead and insert another cell below. Okay, so we have we want to go ahead and create this program, and we want to loop through this. We want to keep track of all of the 5s and 8s with variable k. So we'll just go ahead and k is going to be a counter. We'll start that at 0. And then we'll set up 2 loops. Now these are going to be nested loops, so loop inside a loop. And what we'll do is we'll go ahead and arrange, okay, a range, which is, if you want to do a help on that, let me just go ahead and do a help on, okay, help numpy a range. Okay, you can see this is a built-in function, and it gives you a start, stop, and step. Okay, whereas range before only did you know, integer values. You know, a range is just a little bit different. It's part of the numpy instead of the built-in base Python package, which doesn't use the numpy in front of it. Okay, so anyway, we're going to go ahead and just use the a range there, and we'll do a for I in numpy a range. Okay, and then we'll do numpy size a comma 0. So we're going to say the number of rows that we have in our matrix. Okay, so that just gives us the size of the number of rows in our matrix, and we're going to go ahead and cycle through also the number of columns as well. Okay, so there's the number of columns. Okay, then we want to test each of these elements. So if ai comma j, okay, so we're going to use ai comma j if it equals 5. Okay, so I is going to be our row index, and this is going to be j is going to be our column index. So if it equals 5, or the aij, if that equals, don't forget the double equal sign there, then we're going to then print the index. Okay, so that's going to be index, and then let's see. So we want to do I, j, and j there. Okay, so that's going to be, let's just go ahead and start that off with, okay, and then we'll have to do make this I into a string, and let's go ahead and put a comma in between those, and we'll also print the j as a string, and then put a close bracket there, and then we'll kind of merge those with this plus sign. So we'll concatenate or string together these different elements, okay, to make it into a string that we'll print, and then we'll also increment. We'll do the plus equals 1, so that's going to increment k by 1. If we did 2, that would increment k by 2. Okay, so that's equivalent to doing something like k equals k plus 1, but that happens so many times in programming, they kind of have a shortened way of doing that. Okay, so we just increment k by 1. Okay, and then else if, okay, aij, and if it equals 1, then we'll print you win. Alright, so there it is. You've won if it hits 1. And then at the very end, we're going to go ahead and print, make it nice, so k equals, and then plus, we'll make k into a string, and then go ahead and print it. Okay, so there are all of our, there's the results right there. If you want to put in a little help here, you could also say, you could say testing. Okay, so just to see how this thing is going to proceed, you could say testing these. Okay, and then when it finds those indices that are equal to, 5 or 8, then it's going to print the index. Okay, so it tested all of them. You'll see it run through all of the rows, 0 through 4, and then also all the columns, 0 through 4 as well. Okay, then go ahead and just comment this out so you don't see everything there, but you want to get a feel for arrays and cycling through them with these nested for loops right here. Okay, so these are nested for loops where it will first of all increment I and then go through all of the j's. Okay, execute those lines and then come back up here and execute the next I, and then come back down and execute all of the j's. Okay, so it'll visit all of the elements of our array. Okay, so that's this problem. Let's go on to problem 4. Okay, so we have the following arrays, matrices and vectors. Okay, so arrays, if they're 2D, they're going to be matrices, one-dimensional is vectors. Okay, so A is going to be our matrix, X is going to be vector, and then B is a matrix. We want to perform the following operations. Okay, so we have A and then this circle B, that's an element-wise multiplication, and then A dot B, that's a dot product multiplication, A cross B, cross product multiplication, and we'll have A dot X, and then A inverse times dot product B. Okay, so let's go ahead and do just part A. First of all, we'll just define these. Okay, so define an array where you know the values. Inside here, we're going to just go ahead and put the these types of brackets and then some square brackets, and then we'll define for each row we'll have a separate set of square brackets, and we'll separate them with commas. Okay, so here is our first row right here, and that'll be 1, 2, and 3, and then we'll have 4, 5, and 6, and then 7, 8, and 9. Okay, and then you know, if you want to print a, just to make sure you got it right, you'll see there is your matrix. Okay, and then we'll go ahead and define x as well. Okay, in this case, we just have, you know, this is going to be 1, 2, and 3. Okay, and then if I print x, okay, so there's my 1, 2, and 3. If I want to transpose this, then I would need to, you know, it would, this is right now a row vector. Okay, so I can transpose this, and let's see if I remember. Let's do a help on Numpy transpose. Okay, let's see if, so this is a transpose function. So what we want to do then is on the outside of this, we want to do a transpose and to make it into a column vector instead. Okay, let's see if that did it. No, it still did not. We didn't transpose it. Okay, so I'm gonna have to think about how to do that a little bit more. Another way to do it is just like we did before. We can put these into separate rows like this. Okay, and then it will give us a column vector versus a row vector. All right, and then I'm going to define B as well. This one is very similar to A, and okay, and then I've got to input these the numbers here that were from the B vector, and those were not 1, 2, 3. I need to modify these. These are going to be 1, 3, and 4. Okay, and then here I'll do let's see, negative 0.1. Let's see if I've got those. Negative 0.2, negative 0.3. Okay, and then 3, 10, 2. 10 and 2, and then 4, 2, and 0.5. Okay, there we go. Okay, so I have all of these defined. Let's see, I've got an error here. It looked like B, it's not superscriptable. Okay, so I needed to put an opening parenthesis there, and then a closing parenthesis there as well. Okay, so if I print, the only one I haven't printed yet was B, just to check it. It's a good practice just to make sure that you've got them defined correctly. Okay, so there I've defined them. Now let's go ahead and do some of these operations with them. What we're going to do now is you know, start off with just A times B. So this is the first one, which is just an element wise. You know, every element we're just going to multiply one by the other. And so if we just print A times B, then that's going to be an element wise. Just took the 1, 1 element, the 1, 2, for each of them, just multiplied them together. Now that doesn't happen very often in engineering or math. We don't typically do element wise operations. So let's do the dot product, which is a much more common one. Okay, which is you do the dot function, dot product function, and then put your first one times the second one, and then you can either just have it display like that, or you can put a print in there. Okay, and be able to show that you know, the dot product of those two. I'll go ahead and insert one more. Now the cross product, okay, very similar, but it's just going to be dot cross and A comma B. Okay, so there's the cross product, and okay, so the next one we want to do is A dot X. Okay, so we'll print np dot A comma X. Okay, and there it is. We needed the same inner dimensions. If we had x defined differently, okay, let's just see if we get an error here. Okay, 1, 3, 4. I'll run that one again and then run this one again. Okay, I can see it just returned, it figured out the dimensions, but returned a row vector instead of a column vector. Okay, all right, I'll run that one and then run this one again. Okay, so there's my column vector. Okay, so one more cell below. Okay, now we want to do the inverse of A times B. So we want to do this one right here, this last one, A inverse times B. Let's go ahead and just first of all compute A inverse. Okay, so in order to do that, there's actually one more thing that we need to insert here, and that is from Numpy. You can either do NP linear algebra, okay, dot inverse A. So it's kind of confusing, but it's within Numpy, it's within the linear algebra function, and it's called the inverse. Okay, so we're going to invert that matrix. Okay, now if you want to shorten this down, you don't want to have to put all of that in there, then we can just say from Numpy dot linear algebra import inverse. Okay, and then we can just do the inverse of A, and that'll give us the same answer there. Okay, so what we want to do now is do Numpy dot, we want to multiply the inverse of A times B, and then go ahead and print that out. Okay, so now we're doing some matrix operations here, and there we have the solution. Okay, so that's all there is for this homework. So just to review, we did 4 problems here. We started off with just some basic NumPy, to create a new arrays. Differently, we can either use the linspace, we can use the zeros, the ones, we can create a loop, and show that we can get the same thing both ways. Okay, here are some random numbers here, some random integers, and we basically built this as we went by appending to the end of our vector an additional value, and then we did some checks along the way until it equaled 7. Okay, did some basic stats on it. NumPy mean, just the mean value, and also how many elements there were. Okay, we reshaped an array into a matrix, and then we did some tests on it, equal to 5 or 8. If it was 1, then you win. Okay, and then problem 4, we just did some basic operations on arrays, including dot product, element wise, cross product, and doing the A inverse times B. So that concludes this one. I'll post this under the solutions right here on the course website.